Okay, so today we're going to talk about polynomial inequalities in one variable and how we're going to graph them and tell whether they're positive or negative. The first thing we need to do is take a look at the polynomial inequality, factor it, take a look at those factors, and then test values. We're going to do that using a sign chart. I think it's important to understand before we begin that when you have a graph of a polynomial, it changes sign at the x-intercepts or where we have a vertical asymptote. Let's take a look at an example. We have the problem x squared minus 7 over x squared minus x minus 6 is less than 1. I need to find out what values of x, when plugged into this fraction, make it less than 1. But to do that, we're going to change the problem ever so slightly. Minus 1 less than 0. It just makes it easy to compare. It is easier to compare the function to 0 than to 1. I'm going to get a common denominator, combine like terms, factor, and then do a sign chart. Let's see how it works. This will become x squared minus 7 minus x squared minus x minus 6 over x squared minus x minus 6. Still less than 0. We will combine like terms upstairs and factor downstairs. The x squareds go away. The negative 7 adds with the 6. The x becomes positive. Arguably, it was positive all the time. And I can factor the denominator. Now at this point, we have to think a little bit. And this is when we realize that this last version of my function changes signs only at x-intercepts or vertical asymptotes. We have an x-intercept at 1, a vertical asymptote at 3, and a vertical asymptote at negative 2. We will now use what is called a sign chart, because f only changes sign at those points. Negative 2, 1, and 3. That's it. Action occurs nowhere else. At negative 2 and at 3, the function is, sadly, undefined. At 1, the function is 0. And now, we are simply going to test some values. Think of a number less than negative 2. How about negative 3? Negative 3 minus 1, negative. Negative 3 minus 3, negative. Negative 3 plus 2, negative. Negative divided by negative times negative. Let's think of a number between negative 2 and 1. How about 0? 0 minus 1, negative, negative, positive. Negative divided by negative times positive. Okay. Now we think of a number between 1 and 3. How about 2? Positive divided by negative times positive. And now, let's think of a number bigger than 3. How about 4? Or 513? Positive divided by positive times positive. Now, because I understand that interesting things happen only at zeros or vertical asymptotes, I can look at my sign chart and say that this function is less than 0, which is the same thing as saying this is less than 1, for negative infinity to negative 2, and from 1 to 3. And that is how we will solve a one-variable polynomial inequality. Thank you.